to speak about excitation, contraction, coupling. And this is how we regulate this process. So understand that cross-bridge cycling is the process of shortening the sarcomere, is the process of contracting the muscle. Excitation, contraction, coupling is how we use calcium to turn this on and turn this off, okay, to regulate this process. So there's a sequence of events here where from the action potential getting to the sarcolemma, that should be very familiar to you at this point. We spoke about the neuromuscular junction, the presence of acetylcholine, all that good stuff. The depolarizing event on the muscle, on the motor end plate, which we call an end plate potential. That end plate potential then gives way to this process, and we'll talk about how. So from the end plate potential reaching the sarcomere, that's going to require calcium being released from its storage area in the sarcoplasmic reticulum and flooding the sarcoplasm of this muscle cell. If calcium is not in the sarcoplasm, we already said this process cannot take place. That troponin complex needs to bind calcium to uncover those binding sites. So it's really important to understand the role of calcium in turning this on and turning this off. A lot of this is review. We talked about this extensively, right? So the motor neuron innervating the muscle fiber, the presence of acetylcholine crossing the neuromuscular junction, binding onto the motor end plate. We talked about the acetylcholine receptors on the motor end plate, which were specifically nicotinic receptors. And so the presence of acetylcholine binding to those receptors opened up this channel that allowed potassium and sodium, which then depolarized this cell. Okay, that should all be a review for you at this point. And that brings about an end plate potential on our muscle cell, on our muscle fiber. And so the purpose of that end plate potential is to send this voltage change through the muscle, and that voltage change opens up these receptors that are on the sarcoplasmic reticulum, allows that stored calcium to leave the sarcoplasmic reticulum, to flood the sarcoplasm or the cytoplasm of the cell, to interact with troponin, and to uncover the binding sites. This is really, really important. So the role of calcium is to bind to troponin and drag tropomyosin, that thread-like protein, off of those binding sites. So if we uncover those binding sites, they're now free for myosin to reach up and to bind to actin, okay? If there's no calcium, that cannot happen. So they can reach up, they can bind, they can form this cross bridge between actin and myosin, and then we can have that cyclical process of cycling continue, okay? So I'll stress here, the big take-home point here is this does not happen if there's no calcium. Calcium is released because of the end plate potential, and the end plate potential translates to muscle contraction, that releasing of calcium, which allows actin and myosin to be able to interact. Okay, any questions so far? Any questions so far? Any questions? Okay, so this will make a little bit more sense. I'm going to just summarize everything I just mentioned in these 6 steps of excitation, contraction, coupling, okay? And a lot of this will be review. A lot of this will be review. So we mentioned our motor neuron, okay? This is a motor neuron, and we talked about the storage vesicles here that have acetylcholine. Now, acetylcholine is released when the action potential gets here. You should know those sequence of events by now, that voltage-gated calcium channel opening up, calcium rushing in, exocytosis, these vesicles dumping their neurotransmitter, and that neurotransmitter crossing the junction and binding onto these nicotinic receptors. Once that happens, we have the depolarization on this motor end plate, on this muscle cell, which eventually brings about an end plate potential. When we have an end plate potential, okay, this allows that voltage, that action potential, to travel all throughout the muscle. Does anyone remember what this green structure is? Does anyone remember that green structure? I mentioned it last time. The T-tubule, perfect. So the T-tubule are these invaginations that run through the muscle. And I kind of mentioned their purpose before, but we can really see their purpose now. Their purpose is to help the action potential propagate all throughout the muscle. So when we get this end plate potential here on the motor end plate, it needs to go throughout the muscle very quickly. And that's the purpose of these T tubules, to help facilitate that action potential moving throughout the muscle. Now, when it moves throughout the muscle, it is going to trigger the release of calcium from its storage area, the sarcoplasmic reticulum, into the sarcoplasm or the cytoplasm of the cell. Understand that those are two different compartments, okay? Calcium is being stored in the SR, whereas there isn't calcium in the cytoplasm. And so the end plate potential or the action potential triggers the release of calcium from these storage vesicles, not vesicles, from the storage area, which is in the sarcoplasmic reticulum, out into the cytoplasm, okay? And I'll talk about how that happens, because that is a little bit more complicated than that. But that calcium is then released, and then calcium can now bind onto troponin, and that will uncover these binding sites. Okay, I keep mentioning this because it's really important to understand. If there isn't any calcium, myosin cannot bind to actin. Only in the presence of calcium can tropomyosin be dragged off of those binding sites, those myosin binding sites. Myosin is now available, those binding sites are now available for myosin to reach up and to bind there, okay? And then we have myosin reaching up, grabbing onto these binding sites, cross-bridge cycle begins, right? Myosin drags actin towards the M line, and that is how the muscle contracts. Now, after this process happens, calcium is transported back into the SR. It's really important to regulate this process. We don't want muscle contracting indefinitely. All right, so calcium needs to be removed from the cytoplasm and put back into its storage area in the sarcoplasmic reticulum, okay, in the sarcoplasmic reticulum. Oops, all right. And so the last part of this is when calcium leaves the cytoplasm, troponin now does not have calcium bound to it, and so those tropomyosin, those thread-like molecules, will now shift to cover the binding sites again. Really important in understanding how the presence and absence of calcium determines whether or not actin and myosin can interact with each other because of the covering and uncovering of the binding sites, okay?